Converting between degree and radian measure, problem type 1. In mathematics, radian measure is an incredibly powerful tool for discussing angles, but it really only becomes important in calculus level math, so it is a new way of thinking about things. You are probably already familiar with the ideas of degree measure, and degree measure talks about the angle as the rate at which the lines separate, or sometimes you see degree measure talked about in terms of, in a centralized circle, compare the fraction of the area inside and outside. So the entire circle is 360, so the shaded part over the entire area is a fraction over 360 of the entire circle. Radian measure specifically thinks about distance. If we draw in the entire circle and we think just about the part of the circle inside the angle, how long is that distance? If we determine that the radius of the circle is 1, then the distance here is the radian measure of the angle. An angle of 1 radian is a wedge of a circle where the two sides are both 1 and the curved distance on the outside is also 1. So, taking advantage of what we know about circles, we know that if we have a circle of radius 1, that its circumference is 2 pi. So, if we take the radian measure of an angle and divide by 2 pi, that's the fraction of an entire circle. And similarly, if we take the degree measure of a circle and divide by 360 degrees, that is the fraction of a circle. So either way, you get the same result. These things should be equal. Solving one way or another, if I multiply both sides of this equation by 360, I get that the radian measure times 360 over 2 pi is equal to the degree measure. Personally, I find 360 over 2 pi to be a lot easier to remember, but most textbooks say, and hey, these are both divisible by 2, so let's reduce this a little bit. And remember that radian times 180 degrees divided by pi is equal to the degree measure. Or, if I multiplied by 2 pi instead, I would get that the radian measure is pi divided by 180 degrees times the degree measure. So, if I have an angle like 540 degrees, I can multiply 540 degrees times pi divided by 180. And while my calculator could handle this, generally I'm going to look for an exact value. That means that I want my result to be fractions, and I want my result to have a pi symbol left in it. So just playing around a little bit with the fraction, I can rewrite this as 540 over 180 times pi, clearly divisible by 10. And these are both even, so I'll try dividing by 2. Let's see, 54 is going to be 17. So what am I writing? Right. 54 divided by 2, sorry, not 17. "54 divided by 2 is 27, 18 divided by 2 is 9, and 27 divided by 9 is 3. So I get that 540 degrees is 3 pi radians. One more, if I want to look at, say, 400 degrees, same thing. I multiply times pi, and I divide by 180 degrees. And again, you could just punch this into your calculator, but we still want an exact value. That means we have to play around with fractions. But I'm going to use the same trick of playing around with my fractional multiplication. 400 times pi over 180 is the same thing as 400 over 180 times pi, right? Commutative property of multiplication. These numbers are, again, both divisible by 10. And here they're both even. So I get 20 over 9 pi, or 20 pi over 9.